The focus of this chapter is descriptive statistics, where we will try to find out the properties of central tendency, measures of variability, descriptive summary measures of population, and last but not the least, covariance and coefficient correlation from the data set we have. However, we will not talk about box plot or how to even construct it in this particular chapter. Now, when we have a set of data, first thing we do is construct a frequency distribution table, or at least get the frequency distribution of this data set. And frequency distribution has some important characteristics. They are modality, symmetry, central tendency, and variability. Modality can be of two different types. It could be unimodal or bimodal. Symmetry also can be compartmentalized into two different categories, symmetric or asymmetric. The way we define a symmetric distribution, if the relative frequency or probability is the same on either side of the center. So when we look at the center and the two areas on both sides are equal, we call it a symmetric distribution. Normal distribution is a classic example of symmetric distribution, and we'll be using it extensively. On the other hand, we also have asymmetric distribution, which are positively skewed and negatively skewed. If the tail tends to be longer towards right, we call it skewed to the right or positively skewed. When the tail tends to be longer towards left, we call it skewed to the left or negatively skewed. In addition to that, we will also talk about central tendency, which will include mean, median, and mode. And last but not the least is variability. In this scale, we'll talk about standard deviation and also range. Without further ado, let's talk about what is meant by central tendency, how do we define it, and what are the measures of central tendency. So like I said, central tendency is basically the value, single value that tends to provide be able to capture the entire data set. So again, central tendency is a single value used to describe the center point of a data. Having said that, what is the most popular measures of central tendency? The first thing that comes to mind is the mean or the average. So let's talk about mean. So how do we define mean? And how do we calculate mean? Mean is also called average. Mean or average. So we basically sum up and divide it by the number of observations. So we collect the data set, we add them up and divide by the number of observations. For example, if we have numbers 1, 2, 5, 7, 6, 2, 4, 5, to 1, 2, 3, 4, 5, 6, 7, 8. The mean for this particular data, it would be represented by x bar. X bar would be sum of x, which is a fancy way of writing it. I equals 1 to 8 divided by n. So in this case, it would be 32 divided by 8 equal to 4. So in this case, our mean is 4. Let me reposition the mean. Mean is 4. However, what happens if we replace 5 by a different number, 50? So we have this whole data. So we replace 5, 7, 6, 2, 4, 50. So that's the new number. Instead of 5, we have 50. How is that going to influence our mode? So in this case, the mean. So in this case, the mean is going to be not 32 anymore. If we add all these numbers up, that is going to be 80 divided by 8 equal to 10. So in other words, what we can say is mean is very sensitive to high and low numbers. It is very sensitive. So any outliers or really high number or really low number tends to influence the mean. Although mean is very popular because we have only one number to deal with, it may not be the best thing to do. So again, mean is very popular, but the only disadvantage of using mean is that it has too many, it is influenced by the big numbers, the big and the small numbers. So in that sense, it's not an ideal thing. The next thing we're going to talk about would be what is called sample mean and how do we represent population mean. So we have to be careful the way we designate sample mean and population mean. Sample mean is always represented by small x bar equal to I equals 1 to n divided by small n. Small n is the sample. On the other hand, population mean is represented by this Greek alphabet mu. It is represented by mu, sum of I equal to 1 through n, xi in this particular case, xi, and in this case is divided by capital N. Capital N is the population size. So these are the couple of things that you ought to remember This is how we represent sample mean. This is the formula for sample mean, and this is the formula for population mean. Let me give you an example. Suppose you took a stat course which had 4 exams, and these are the respective exam scores that you have. Stat exam scores. So suppose the scores are 89, 95, 87 and 97. In this particular case, this is not a sample, this is the population, because you have taken all the exams. In this case, data set is a population because all of your exam scores are included. So in this case, we can look at the middle, mu, and if we add all of them up, 89 plus 95 plus 87 plus 97 and divide by 4, average 92. So that's one way of looking at what is called population mean. And again, this would be summation xi divided by capital N. Capital N, so that's the thing you need to keep in mind. The next thing we're going to talk about would be median. But before that, let me just say a couple of good things about mean. The advantage about mean is it has only one single number. It has a single value, and that's an advantage. However, the other disadvantages, as I have pointed out, they are susceptible to extreme values. For example, if you are teaching a traditional course with the age group is 18 to 22, so and you have about 20 students, the class average would be between 18 and 20. If you have some non-traditional students or go 60 students, maybe 2 or 3 of them in the class, which would be in the upwards of 60, that will definitely bias the outcome, or that would definitely make the mean average age of students in the statistics course higher than they what actually are. So so in that regard, mean may not be the best way out. So what is the answer to that? We'll talk about median. This is another measure of central tendency. We look for the halfway point or the middle point. Middlemost value, typically what we do when we receive a data, we put them in an ascending order, meaning from low to high, and we look for the middlemost value, and that is typically what is your median. So suppose we have a data set with odd number of it's an odd number, 1, 7, 10, 12 and 14. So if we put them, it's already been put in a sequence, so the middlemost number is 10, and that's your median. But how do things change if we have even number in our data set, if the number is even? So then what we do is we just add up the middlemost number, two middle numbers, and divide it by 2. So in this case, the median would be 10.5, and it's right here, smack right here, 10.5. We also call it the 50th percentile, which we'll get into in a little bit. Again, as I have indicated, mean is influenced by extreme values. Median, however, is not. In fact, there was a recent article in Wall Street Journal which talked about how women's wages outpaced men's during the 2009 recession, and they gave the median salary. Now, why they did not give the mean salary? The reason for using median salary is if we put them from a higher to a lower, from a lower to a higher order, the good thing about the median is your middlemost value will not be influenced. Suppose you have a new hire who makes $10,000, and suppose the median salary for Berks County is $40,000. So is that going to impact your median? Absolutely not. However, if we talk about mean, the 10,000, if some new hire gets 10,000, that is definitely going to drag down the mean salary. However, median will not be impacted because it's the middlemost number. So whenever we talk about salary range, or whenever we talk about how home prices, we use median rather than mean. Also for home prices, when we use median, the advantage of using median is if there is a house which is worth $50,000 in your neighborhood, your house price will not be impacted. On the flip side, if you have a house which is worth 1.5 million, neither your house price is going to jack up. So in that sense, median is a better representation than the mean. And there is a formula we use to calculate median. So median would be, let me use the color of the pen, n plus 1 divided by 2. N plus 1 divided by 2. Again, my handwriting is getting atrocious, and I apologize for that. Remember the stem and leaf graph we used in my previous lecture? If we use the same data, we can also be able to figure out the median for this particular group. So if we put them in an ascending order, it should be somewhere, the position should be 10.5. So if we count from the lowest number, so the median should fall between 38 and 39. So in this example, the median age of people that work in this particular company is 38.5. The next important measure is what is called mode. Mode typically tells you how frequently a data has occurred. And if you look at this mode, at this data set, obviously 2 is the mode. What happens if we have a data set to make it bimodal? We have to have 3 1s and 3 2s. So this would be an example of bimodal. Please do not put 0 because it is inappropriate or it's incorrect. So you need to use, so this is one group and that's the other group. So it's a unimodal, bimodal distribution. And this is a unimodal distribution in the previous example where 2 was occurring the most. We can also use mode in a different way. Suppose we are looking at Best Buy, selling TV brands, Best Buy and TV brands. So suppose they have Sony, Panasonic, also put a couple of them here, Samsung, Sharp, etc. Suppose Sony sell 21 TV in a week, Panasonic sold 27 in a week, Samsung sold 18, and Sharp sold 15. So again, using mode, we can say that in terms of brand, Panasonic is the most popular one. We're not talking about anything else, just the number of units that we sold at Best Buy. So the next thing we're going to talk about would be how to calculate variability or measures of dispersion. So variability is a very important factor, and one of the simple way of calculating variability or variation is the range. So we have variation, there are 4 different components, 4 different ways to calculate variation. We can look at range, we can look at variance, we can look at standard deviation and coefficient of variation, standard deviation and coefficient and coefficient of variation. So variability basically talks about the spread or the dispersion of the data. So variability or variation talks about the spread or dispersion of the data. How the data has been spread, or what is the spread of this particular data. Spread or dispersion. Spread or dispersion. So if we look at this particular chart, so again see sometimes we have problems with mean. So suppose we have this diagram, suppose this is one normal distribution A, and this is the mean, sample mean x bar, and suppose we have another normal distribution B, with the sample mean is also is y bar. So they both have the same sample mean. Please excuse my graph, but the dispersion is wider. So A tends to be wider than B. The easiest way we calculate variation is through range. So range is basically the smallest value when we subtract the smallest value from the largest value. When we subtract the so in this case we're going to subtract, suppose we have data, suppose we have a data set 12, 9, 3, 16, 42, 53. So the range in this case would be 53 minus 3, which is 50. So you look at the largest data and look at the smallest data and just subtract the smallest data from the largest data. Variance is a little more complicated. Under variance, we have to look at the distance from x bar and how far it is away from the mean or from the center. So in this case, I think we can look at a particular example to show how to calculate variability or the variance. And the formula for variance is this. This is a square. This is again for sample variance. V a square equals x1 minus x bar square divided by n minus 1 summation I equal to 1 to n, where we have samples x1, x2, x3 dot xi and n equal to sample size. N is our sample size. And the thing that you need to remember, that why do we have n minus 1? So the largest sample size that we can have from a population is one less from the population. In other words, suppose there are only 100 40 let me think of an example. Suppose there are 500 Ford Model T vehicle, Model T Ford vehicle which is in good shape in the whole world. That is the population. if we pick any 499 out of 500, that would be the largest sample that we can have, given that the population size is 500. So that's the reason why we divide a square by n minus 1 and not by n. So again, I'll put this thing here. Remember during the calculation. So you please remember that this is n minus 1 and not n. So this is our variance and the way we calculate standard deviation. Standard deviation is essentially root over a square, which is sum of xi minus x bar square divided by n minus 1, the whole thing raised to the power 1/2. The same thing as taking the square root, is the exact same thing. Now let me give you a very simple example of how we calculate standard deviation. How we calculate standard deviation. Suppose we have the calories from cereals, which is 80, 100, 100, 110, 130, 190, and 200. The first thing we ought to do is calculate x bar. In this case, our x bar is and again in this example we calculate x bar. And x bar in this case is 130. So this is what we would call our, okay, let me move up a little bit and see how it works. Calories from cereal. So let me use this one as xi. This is, no, I want to use a different color. So this is xi. This is xi minus x bar. This one is xi minus x bar square. So basically xi minus x bar would be 80 minus 130, 100 minus 130, 100 minus 130, and we just follow the process. 0, 190 minus 130, and 200 minus 130. So we have negative I guess I can erase this one and do it. So minus 50, minus 30, minus 30, minus 20, 0, 60, 70. And then we squared them up. And then we square it. 2500, 900, 900, 400, 3600, 4900. So once we add all of them up, we have 13,200. And then make sure you divide that number by 6. Here we have 1, 2, 3, 4, 5, 6, 7. So s square is 13,200 divided by 6. Let me make it look more visible. And then the next would be 2200. So this is our variance. And our standard deviation, you just take a square root. Root over 2200, which makes it 46.90. So that's typically how we derive standard deviation. It is pretty straightforward. The only thing to remember is when you divide the number, whatever the sample size is, it should be n minus 1. So that's the only thing to keep in mind, and obviously do the calculations correctly. The next thing we're going to talk about would be, besides calculating mean, median, mode, standard deviation, and variance, we'll talk about what is called coefficient of variation. This is actually very, very important. Coefficient of variation. And the coefficient of variation of CV is basically an entity with no units, because when we look at the coefficient of variation, it is a ratio of standard deviation over mean. So if standard deviation is in pounds and the mean are also in pounds, the units cancel. If the standard deviation is in miles and the mean is also in miles, then the units will cancel. So in that sense, this is a pure number and we don't really have to worry about any units. So going back to the previous example, the standard deviation in this case is 46.9042, and the mean was 130. So once we divide 46.9042 by 130, we have, one other thing, you need to multiply that by 100. So whatever the number is, multiplied by 100. Again, let me fix this stuff here. Times 100, 100%. So that was 17.10%. And there are certain usages, or usage of coefficient of variation. Suppose we have two assets, asset A and asset B. A, asset B. X bar A equal to 15, X bar B is equal to 15%. So that's the return. On A, return on investment B. What we do next is look at the variability. Let's draw a graph. Let's show how that works. Suppose this is asset A, and this is asset B. In this case, what is happening? Suppose the standard deviation of asset A is 94%, and standard deviation of asset B is 32%. Again, these are all hypothetical numbers. I'm just drawing from my head. So if we use the coefficient of variation, so coefficient of variation for asset A would be equal to, it would be 94% divided by 15%, and coefficient of variation for asset B equal to 32% divided by 15%. Let me calculate the number real quick. Equals 6.26. Again, 6.26 2.13. So basically what it tells you, and then we look at the coefficient asset A over coefficient of variation for asset B, 6.26 over 2.13, 6.26 divided by 2.13 equals 2.93. So this number 2.93 basically tells you that asset A is 2.93 times more risky than asset B. So by looking at coefficient of variation, which is again unit free, we can figure out to the nearest, we be able to figure out, comparing these two different assets A and B, how much asset A is riskier than asset B. So if asset A is 2.93 times more riskier than asset B, then the average return should not be 15%, it should be higher, because higher the risk, higher the return, lower the risk, lower the return. So if the return for asset B is 15%, that's good, but asset A, since the risk is much higher, the compensation should not be 15%, it should be adjusted for the amount of risk. The last thing we're going to talk about in this chapter, no, not in this chapter, in this particular lecture, is what is called the Z-score. The Z-scores what basically Z-score does, if you have an extreme value or outlier which is far away from the mean, the Z-score takes the difference between this extreme value and the mean, and you divide that number by the standard deviation. So if you have so that's basically what Z-score tells you. So Z-score is essentially the difference between the lowest, the most extreme numbers and the value of the mean. And this is designed to basically locate extreme outliers. Okay, with that we'll conclude this particular lecture. Thank you.